Okay. Can you hear me? Can you see the slide?
Okay.
Okay, thank you. Okay, so today we will continue with step counter method. Okay, so I think last week when we did the design tutorial, so I didn't manage to cover because of time constraint. So today I will just try to finish this part of our step counter method. Okay, so briefly, it will be a short class. So I hope you can focus. So mostly I already explained in the Add Puzzle video on the steps that you need to take for the step counter method. But I will just try to cover in the class also for your understanding. Okay, for your information, we will have step counter method and cascading method for our midterm test. So it's very important for you to understand how to do it. Okay, so briefly about step counter method. So step counter method is one of the method that we use for signal elimination. Okay, to avoid signal overlap. So it is designed to prevent the occurrence of opposite signal from for two or more cylinder movement. So meaning it's a signal overlap. Okay, so opposite signal meaning is a signal overlap. So for step counter method, we use a counter counting module, CCM. Okay, counter counting module. So what is CCM? So it is consists of two valves. Okay, so at the dual valve. So the first valve is pneumatic injected 3/2 valve. Okay, so 3/2, 3/2 valve, and you have a N valve. So you combine both of these to form a, step counting module. So you can call it as a step counting module or counter counting module. Okay, so normally we will use the term step counting module. Okay, so this is on the introduction for step counter module. So let's see uh, how the step counter module counting module is formed. Okay, so to build a step counter circuit, you need a step counter module that consisting of 3/2 valve and N valve. So you can see, so you have a 3/2 valve and you have an N valve. Okay, so this is an N valve, this is a 3/2 valve. Okay, so it has a six connection. So you can see connection one, two, three, four, five, six. So this one module is for one sequence. Okay, so we will use. So if your circuit has six sequence, so you will use six step counting module. So each sequence will use one. Okay. Okay, so warning, you must complete the step counter module as shown in the figure below so that not to be confused with construction of the step counter circuit. So make sure you draw your step counting module like this. Yang ni sebelah kanan, yang ni sebelah kiri. So make sure you draw similarly. So don't replace it. So don't put this in on your left and this on the right. So you will get confused. Okay, so try to draw it this way. Okay, so you have six connection. So what are the six connection? So number one, signal from the previous sequence. So you have a sequence beside you. So you will get this signal for number one from that module. So number two is signal response from the last step. Okay, so we will see later. A signal to direction control valve, so it's connected to the direction control valve. So push back the last three O2 valve to the initial position. Okay, we will see this later also. Step setup signal from upcoming module and signal pushback the 302 to the initial position. Okay, so we have few. Okay, so we have few connections. It's six connection for you to uh, understand. Okay, so we will see one example. Okay, this example is almost similar like the one that we have done for the design tutorial. Okay, so to cut it short, so this is the sequence. Yes, so this is the sequence. So the rest we just follow similar like last week. Okay, so to connect the circuit from the module to the power valve, you need to follow the steps. Signal from step counter module top. The first module is connected to A1. Okay, so because here after A plus, A1 will be on. So first module is connected to A1. So second module is connected to B1 um, because is B plus. Third module is connected to B0 because it's B minus, and fourth module is connected to A0 because it's A minus. Okay, so we need to know this. Then you need to join it. So this step is practically your motion diagram. Okay, motion diagram we didn't draw here, but they are explaining it in the sentence form. So dalam bentuk ayat. So from the tutorial that we have done last week, so we know that it's better for us to draw in a motion diagram or step displacement diagram. Okay, so you can use that. So A0 valve is connected to the start valve ST and then connected to valve N on module 1. Saya boleh baca lah, so you can read here. So these are the circuit connections that we will use. Okay, so A1 valve is connected to N on the second module. So each switch will be connected to the respective module. So you need to know which module for it to be connected. Okay, so you can see, so A plus, so yeah, so this is one module. Okay, so how you want to draw? So draw according to the sequence. So A plus, B minus, A minus. So if your sequence is A plus, B plus, A minus, B minus, it still will be the same. The only thing that will change is the symbol, this name, notation. So A plus, B plus, because it will be the same. And the connection where it will be connected. Okay, so this is a step counter circuit. So you can see, so there's a start button and also A0, so A1, B1, and B0. So you need to draw it accordingly. Okay, so this is with the connection. So try to design this in your fluid sim to see how it will work. Then you will understand it better. Okay, so we'll see one example. Okay, step by step, how the circuit is connected. So this is a six sequence case, meaning you have A, cylinder B, and cylinder C. You have three cylinders and six sequence. Okay, so A plus, B plus, C minus, B minus, A minus. So it's a simple one. So since it has six sequence, so other six sequence, so you need to use six step counter module. Perlukan, so meaning your 3/2 valve and N valve kena ada 6 set, must have 6 set. Okay, and you arrange it according to the sequence here, alphabets. Okay, so to connect the circuit from the module to the power valve, you should follow the steps below. Okay, the first module is connected to A1, second module is connected to B1, then third module to C1, fourth module to C0, fifth module to B0, and sixth module is connected to A0. and you can see circuit connection from the step counter module to the valve. So ini adalah sequence lah. So A0. Okay, so we can see from here. So this is your first module. Okay, so for this module you need to write down the sequence. So macam ni kita tulis sequence, so minus mark. Because we don't know what sequence are this. So you need to write here macam tadi. Macam tadi. So draw in a box A plus, B plus, B minus, A minus. So we can see here. So this is module 1. So this is connected to the push button and also the last sequence. The last sequence is A0. Because the last sequence is A minus. So after A minus is executed, A0 will be on. Sebab tu ada gambar dinding. So it will be connected here. And you have this from the previous sequence. Yang ni just sambung. Sambung je. So you can see, so this one will be connected here. 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 This one will be connected here, and this one will be connected here. So all the sequence will be connected to the previous sequence. Sebab tu diambil dari sequence ni. They take from the previous sequence. So previous sequence is this. So it's like in a circle. Okay, so number 1. So number 2 is connected to the valve. So yang ni senang lah. It's connected to the valve. So number 2. Sorry. This is not number 2. Number 2 is here. So it will be connected to the switch lah. Okay. So silap number. So it's supposed to be 1. This is supposed to be 2. So it will be connected to the respective push button. So here we know. So after this is A plus. So after the sequence of A plus is executed, so A1 will be on. So A1 will activate the next sequence. Sebab tu dia letak dekat sini. So after this, so this will be connected to B plus. So B plus are on, so it will activate B1. So B1 will be the next sequence. So it will be according to the sequence that you are arranging. Okay, so here, so the most important part, so yang lain dia cuma kena ikut the instruction. So where it will be connected to the previous circuit module. So the most important one is number 3 here, where this arrow will be connected. So that is the most important because it will determine. So kalau kita bagi dekat here, right. Okay, please off the mic. Shafiq Izam. Okay, so we continue. So the most important one will be this arrow. So if you see from step counter module, it will be number 3. So ke mana dia akan connect? Okay. So if it's connected to the left hand side of cylinder A, so meaning it will make the cylinder A to extend. So kalau sequence ni A plus, so you connect dekat cylinder A bahagian kiri. So if the sequence is A minus, so you need to connect it to the right hand side. Baru dia akan patah balik. Okay, so that is how we can design. So design according to the sequence. So if you can see here, so the fourth one, so it is connected to C minus. sebelah kanan cylinder C. So when you on you give this signal, so cylinder C akan retract balik. So you need to know where to connect it. So once you know where to connect it, so you will know how to design the step counter circuit. Okay, so you can see here also. Okay, so you can see here. Okay, so this is on your step counter module. So any question? Any question on step counter module? So I already gave you an assignment for you to complete. So please complete the assignment because you need to know how to design the step counter circuit using a step counter method. Okay, so that's one. That's the first slide. Okay. If you have question in between, you may ask. Okay. Okay. So if you have question, you may ask. If not, we will take 2 minutes break. Then I will show you another step for step counter module. Today we will see another topic called as step counter method. So previously, okay, so we will continue. One more slide, a short slide. Okay, so please hold on. Okay, so this is actually the continuation of the previous slide. Okay, so, okay, so how to design a step counter? So this is the solution. Okay, so first you write a statement. Okay, then you draw the positional layout. Then you draw the notational form. Okay, so A plus, A minus according to the sequence. So the main thing is the sequence here. Okay, so A plus, B minus, and E minus. Then you draw the displacement step diagram. Okay, so if you have a time diagram, so you can draw that also. Then you have the input signal coming from cylinder A and cylinder B, and the output signal from cylinder A and cylinder B, A plus, A minus, B plus, B minus. Then you draw the power circuit. Okay, so draw the power circuit. So this is the sequence that you need to draw. First, you need to know, so this is your step counter module. Okay, so you have 1, 2, 3, 4, 5, and 6. Okay, so pastikan semua ni ada. Okay, then you can draw accordingly. Okay, we will see one example. Okay, so a pneumatic actuator drilling machine contains of two DAC. When the workpiece is located at the position, the cylinder A will clamp the workpiece. Then the drilling process is started, where the spindle is controlled by cylinder B. So, meaning you have two cylinders, or cylinder A and cylinder B. Okay, so you have two cylinders. It will cylinder A will hold the workpiece, so climb the workpiece. Okay, then cylinder B will drill. Okay, cylinder B drill. Okay, so then cylinder A will release. Cylinder B will release first, then cylinder A. So meaning A plus, B minus, A minus. Okay, so that is the sequence. So you can see, so we need to define the motion. So the motion is A plus, B minus, A minus. Okay, so that is the sequence. So you need to draw four alphabets: A plus, B minus, and A minus. Okay, first draw the cylinders and directional control valve. So this is your two cylinder case. So draw two cylinder. Lukis macam ni. Okay, exactly similar. Okay, with all uh, the limit switch A0, A1, B0, B1. Okay, so this is your sequence. Then after that, draw the four modules. Okay, step counter modules. So module 1. So lukis dulu macam ni. Okay, 1, 2, 3, 4. So make sure you put the notation to your sequence. Okay, for you to know. Okay, lukis macam ni. Okay, so first power circuit, then step counter module. So if you have 6 sequence, so lukis 6 sequence separately. Okay, so sequence start from left to right. So A plus, B minus, and A minus. So lukis accordingly. Okay, so letak macam ni. So senang lah board connection nanti. Okay, so after that, connect input 3 to the respective port. Okay, so 3 respective port. So earlier A plus. So A plus, kalau you hantar signal dekat sini, so what will make cylinder A to move forward? So you kena letak dekat sebelah kiri. So on the left hand side. So you connect this to this side. Okay, B plus is connected to cylinder B left hand side valve. So cylinder B I can extend. So B minus is connected to B cylinder B valve on the right hand side, and A minus is connected to cylinder A right hand side. So look at dulu yang ni. Okay, so we connect number 3 first. Then we connect number 4. Number 4 is connected to the previous module for port 6. So ini adalah port 6, ini adalah port 4. So each module ada port 4, each module ada port 6. Okay, so what you do? So you just connect it. Connect je macam ni. So this is connected to here, this is connected to here. And for this, it is connected to the previous module number 6. Yang ni dia pusing dari sini sampai ke sini. Okay. Step counter circuit, it look like a bit complicated because you have long cables connected. But it is easier to construct compared to cascading. Okay, so after that, so we already settled 4, 3, and 6. So now number 1. So number 1 is connected to previous modules number 5. So 1 is connected to previous module number 5. So this is connected to here. So this is connected to here. And one more is, so this is connected to here. So connect the correct sequence. Okay, then number 2. So all one, everything already connected. So now the last one, number 2. Connect input 2 to the input switches. So what will activate this circuit to extend E plus? So you first you have switch and also A0. So it will be an actuator condition. Then you press the push button. It will give a signal here for cylinder A to extend. Okay, so yani first module. Second module, once A extend, so what need to be done? A plus, B plus. So here A extend, it will on A1. So A1 connect here to activate B plus. So B plus, so cylinder B extend will on B minus, B1. So B1 will activate the next sequence. So you put here, it will activate, it will give signal, so cylinder B will retract, will on B0. So B0 dekat sini. So initially it will be connected. So sebab tu ada gambar dinding. So B0, then what will happen? Your cylinder A will retract. So itu adalah the next sequence. Okay, so this is how you can design. So follow all these steps. Okay, start from this slide. So step 1, step 2, step 3, step 4, step 5, step 6, step 7, step 8. So total ada 8 step. So you have total 8 steps that you need to follow. And this step counter design will be easier because it will be the same from all the circuit. So just the only thing that will change will be here. Okay, so will be port number 3. Okay, port number 3. So you need to connect it to the correct port for the cylinder to extend or retract. So that's the only thing that you need to understand. Okay, so any question? It's just a short one. Ada soalan tak? Anything that you want to ask regarding step counter circuit? Any question?
Tak ada, sir.
Okay. So if you don't have question, so please be prepared for your exam, your test, midterm test. Next week, 1 week cuti, 1 week leave. So once you are back, we will do our test, midterm test. So it will cover chapter 1 to chapter 5. So complete your assignment. And after the midterm test also, we will have quiz 1. Quiz one will be like using word wall, so it will be like in a game form, but it will cover chapter 1 to chapter 5. Okay, so I think that's all. So we won't have anything next week. We will see back the week after. Okay, so thank you.
Thank you, sir.
Thank
Thank you,
you,
sir.
sir.